Hi, we are the Brew Engineers team. Our mentor is Greg Ogden. I'm the team lead, Reagan, and I'm studying industrial engineering.
I'm David, and I'm studying systems engineering.
I'm Vincent, and I'm studying electrical and computer engineering.
I'm Cole, and I'm studying mechanical engineering.
I'm Julian, and I'm also studying mechanical engineering.
I'm the purchasing lead, Madison, and I'm studying mechanical engineering.
We are sponsored by Dennis Arnold over at Brewery Brewing Company, a local craft brewery which brewed its first beer in 1991. They've grown significantly since then, now turning out 15,000 barrels a year. Our project is to optimize the brewery chilling system. The main problem they have been having is the chiller turning itself off in the summer months, which leads to lower product quality and is disruptive to the brewing schedule. Our project focuses on optimizing a pre-existing system within the brewery, so all implementation was halted due to the U of A coronavirus regulations.
Our plan was to implement a two-part system. First, a centralized monitoring system, or CMS, to monitor the different brewing components and alert to any system failures, and the glycol transport system, or GTS, to ensure there is enough cooling power and glycol cooling fluid flow to support the brewery. Now to go over some requirements. We have 4 functional requirements about the optimized brewery chilling system. These include the chilling system's chilling power shall remain greater than the demand at all times. It shall provide by and fermenter tanks required glycol flow to maintain desired temperatures set at each temperature controller. It shall include a centralized monitoring system, and it shall include an alert in case of one or more system failures. Some important system requirements include system shall utilize Arduino. Its baud rate shall be 9600 bits per second. It shall display all tank temperatures on an interactive panel at all times. There shall be an alert when a tank temperature is above or below 10 degrees Fahrenheit of a desired temperature of 28 degrees Fahrenheit for a minimum of 60 minutes, and wetted components shall be glycol compatible at 20 degrees Fahrenheit.
For the centralized monitoring system, we created a site-wide implementation plan that wired the temperature for 20 different brewery tanks, the chillers, as well as the temperature sensor and the glycol tank back to an Arduino processor, which connects to our human-machine interface. We also include a larger monitor that can be easily seen throughout the brewery. We originally planned to wire the temperature controllers, which are located in 5 different electrical boxes around the brewery, back to the main processing components of our system. The diagram above shows the bones, or main beams of the brewery we were planning to run all wire along. When designing the GUI, we took inspiration from the current systems the brewery had in place to keep track of tank and daily task information. They originally had whiteboards around the brewery with similar information and organization as seen above. The GUI displays all this information on the main screen and uses a calendar function to help management keep track of daily tasks.
Now let's go over the feature of our CMS GUI. The first feature is the tank profile. It contains all information of one tank, such as the type of beer, current temperature, and the user can add or modify the day of brew, filter date, crash date, and etc. The user can save all information for update and clear all information for creating a new profile. The second feature is the weekly calendar. It allows the user to design their own plan of work by choosing the type of beer to be brewed or filtered, and user can add daily notes, but only the notes for today and tomorrow will be displayed on the home screen, and today's work will be highlighted and displayed on the bottom right of the home screen. The third feature is the alert to monitor the system failure. This is an example of displaying the warning message on the GUI. The user can also observe in real time to see which tank has the temperature warning. We also conducted 2 tests for the CMS. The GUI should turn on the alert system when the temperature is over 75 degrees Fahrenheit. During the test, I hold the thermocouple in hands and rise the temperature. If it's over 75 degrees Fahrenheit, then the alert system is activated. And if I put the thermocouple back to the water, the temperature drops, and if it's less than 75 degrees, then the GUI will go back to the home screen automatically. The second test is to show that Modbus works for multiple temperature controller. Due to the impact of COVID-19, we have only ordered 1 temperature controller, but we can still do the testing by changing the ID of the device. For example, the tank F2 has a temperature controller with the ID of 4. So now you can see the temperature data is updating and only displayed on the tank F2. The Modbus testing is certified, and just make sure that each temperature controller has a unique ID.
Designing the GTS, we identified the 3 areas of concern as the pump efficiency, the chilling capacity, and the chilling demand of the brewery. The solutions for these problems were to be delivered to the sponsor in the form of a final report. Here you can see one of the testing configurations for the pump efficiency test involving a flow meter, pressure gauges, and a multimeter. The results from this test were to be used to find the efficiency of the pumps used to circulate glycol in the brewery. We will be submitting the test plan and equipment for Barrio to perform the test on their own as part of the sponsored deliverables. The projected chilling capacity was found using the Danfoss software provided to the team by the chiller manufacturer. After selecting various operating parameters for the chiller condensing units, we were able to get these plots showing the chilling capacity and power consumption at the glycol exiting temperature of 28 degrees Fahrenheit. It is important to note that these plots show the capacity of power consumption for one condensing unit. The two chillers at Barrio both have two condensing units, therefore the values are multiplied by 4. From these plots, we gather that the chilling capacity at 100 degrees Fahrenheit was 16.8 tons of refrigeration, and at 110 degrees, it was 15.2 tons. Again, at these same temperatures, the power consumption was 34.2 kilowatts and 37 kilowatts. The analysis for brewery demand took into account the 3 processes in beer production that require cooling: fermentation, crashing, and holding the finished beer at a constant temperature. We then used principles from thermodynamics and heat transfer to calculate the chilling demand of the brewery for a particular load case. We found that the daily required cooling load was 3.487 tons of refrigeration.
Even though the test for the glycol transport system could not be performed, we are still sending Barrio the testing equipment and the testing instructions. When Barrio performs the tests, they can refer to a document that we created, which describes possible solutions to problems that the testing will find. For instance, if the pump tests show that the pump is being overworked, Barrio could add a new pump into the system to distribute the load. They could also think about reconfiguring the pipes to decrease head loss and allow for more direct glycol flow. If the pump is simply inefficient, the pumps can be replaced for a higher horsepower, or a variable frequency driver could be added. Although we performed analysis on the chiller, it was theoretical. We are recommending that Barrio has a professional come in to get it serviced, where the potential leaks will be repaired and the condenser will be cleaned or replaced.
In conclusion, our team finished the project having only spent $760.39. Although COVID-19 prevented our team from implementing our design at the brewery, our team was still able to provide 3 major deliverables to Barrio. The GTS testing kit includes 1 flow meter, 2 pressure gauges, and testing instructions for future implementation if the brewery decides to continue its pursuit of an optimized chilling system. The CMS was still able to be finished and tested, so this will be given to Barrio along with 100 feet of sample wire. The final report will include drawings and testing approaches for both systems for Barrio to use as a future reference if they wish to move forward. The design process taught our team countless lessons, including staying adaptable, being proactive, staying prepared for unexpected circumstances, and learning to communicate with teams, sponsors, and advisors to accomplish a common goal.